We are working on this 2010 Ford F150. It's at my friend's shop, and this is another one kind of no start issue. This one will actually attempt to crank, but then it shuts itself off, and it's sort of intermittent as far as what the customer was complaining about. So as far as what my friend was telling me, he went out to get the truck. It only ended up doing its weird sort of crank and shut itself off. So he went, got a jump box, brought it inside. After it started, he did notice that the battery cable was full of corrosion, so he ended up replacing that. Ever since then, we do have a intermittent no start situation, but I'll get you a shot of what it does when you try to crank it. So I did a full system scan, and we've got a lot of modules basically reporting that they're not seeing the PCM, basically like not communicating. And then we are actually able to pull codes from the PCM, which some of them are these internal control module deals. And here's another one. So I'm not 100% sure what's going on, what the cause is, but those are the trouble codes. So with that, we're gonna kind of look at some diagrams, do some research, see what we can find. As far as what it's doing, let me get you a quick shot. Hopefully you should be able to see it. Hopefully it'll do it. So hold on. So we'll turn the key on, and it's like a delayed start from when you go into the key position. So I'm gonna turn the key to the start, and that's what it does. It'll kick out the starter, but then stop. It's weird. Alright, so right now it's continuous. Hopefully it'll stay that way while we do some testing. Alright, and actually, based off of some research, looks like there is potentially a power supply issue to the computer that can cause this, which is definitely something you want to double check before basically calling a bad PCM based off of the trouble codes. It could be very easy just to go off codes and condemn the module right here, PCM, as faulty and bad. Many of those clues, along with the no communication with the PCM, could lead you to do that if you were to not do any testing. So before we condemn that guy, we are gonna check these three power supplies at the PCM. They are on the connector 175B, pins 42, which is the gray-brown, pins 68, 67, both are yellow and gray. They are both fused from different fuses from the fuse box in the engine bay. So here I am. This is that connector, 175B, I think is what it was. Here is the single brown gray or gray brown, whatever it was, and then the two yellows down there. And here is a shot of the positive battery terminal. As you can see, lots and lots of corrosion. So he's got a new end installed for now, and we are going to do some testing to try to see if we can figure out why it's still doing its intermittent sort of crank. Alright, so we've got the scope running. We're going to do the try to crank it and capture it on here with the scope. So go ahead. Alright. Okay, so here's that no start capture, or the sort of crank no start capture. Not sure if I mentioned it, but the blue trace, I also have the amp clamp around the battery negative because I wanted to look at the starter amperage draw just as a reference or just to see what that was doing. So let's see if let's zoom in at one of the events. As far as the channels go, over here, so in the red, I've got, I think it's pin 42, and then green, yellow, which are overlapping, are going to be pins 67 and 68. These are at the PCM, obviously. And clearly off the bat, we can tell that something odd is going on with the green and yellow, along with that repetitive cycling, let's call it, which I did hear like a little clicking noise when it was not starting or just before the starter kicked out. So that's what we're seeing there. As far as the levels, so we clearly are having a discrepancy or not full voltage on all three pins. So if we go there, and then let's get a measurement on the red, the one that we know is not lower. So our levels are definitely different, and they should both be the same. We've got almost 12 volts and then 9.5. So the 9.5 again is channels green and yellow. They are overlapping, but so that's two power supplies that are feeding it lower than needed voltage out of the three. And so again, before we condemn the PCM, this is why I wanted to look at basically the power feed source to the PCM, because if we're not having all of our true full potential being fed into it, then the PCM can just start to wig out. And so just zooming in now and looking at this, if you think about it, so I think this is where the issue is coming to play. We turn the key on, then we request crank by putting it in the start position. The starter kicks out and it just instantly cuts off all by itself. And I think that it just cuts off because the computer just wigs out, not enough voltage, and it's just not in a good state, and so it just kills itself. And so that's what we abruptly see right there. And I think that is happening because if this was already at 9.5, we're clearly going to drop voltage when we raise our amperage from the starter. So our starting event, when the starter kicks out, is demanding a lot of energy, and so our voltages are going to naturally drop. But if we already started low here on two power feeds, when we crank, we are going to drop even more, and then in the steady point, it's still lower than its low point, and I'll get some numbers here. So let's see, let's see what it drops down to, and then what it holds steady at, or sort of level, not so much steady, because it's got ripple there compared to the red that doesn't. So as far as our figures, so our low point is down to 5.5, and our, let's call it sort of level out point, it's at 7.5 volts. So that's two power feeds going into the computer at 7.5 volts, while the other one during cranking is probably going to be maybe what, let's call 9 or so. It's what you expect to sort of see, or above 9.5. So that one's good at 10 volts, and again, it's steady. It's not having a ripple effect, which let's take a look if we drop that. So yeah, look at the difference. So they're clearly is a voltage feed issue to the PCM on that one leg that provides two separate feeds. So based off of what we just saw as far as the low voltage feed, I think I want to just kind of backtrace. We know that it's coming from a fuse. Both of these are fuse fed power feeds. So I think I want to backtrace towards that fuse, but I don't want to disturb too much again. Just like making these connections, I tapped in. I hadn't unplugged the computer connector or anything. I just tapped into the wires. I'm not trying to disturb too much right now. So I'm gonna not pull the fuse out, maybe just on the top, touch that metal pin. I want to crank it while touching the pin, watching the voltage at the fuse, and see if it does the same thing as it does here at the computer. If it does not, then we know it's something in between. If it does, then it's something at that point or further back. All right, so based off of the scope capture, I wanted to backtrace from the computer voltage measurement that we took back here to the fuse panel. The one trace that we saw that was lower than it needed to be and had that weird like flickering activity on it was from fuse, I think it's fuse 75, this 15 amp right here. I added an additional trace, and I didn't want to disturb anything yet by removing it and putting an adapter in and monitoring. So I just tapped the top of it with a back probe, and once we did, the truck started. And that was the only thing that I changed, was kind of pushing down on the fuse with the back probe with this guy here. So that's all I did. I was going to monitor it while cranking, and it started up. So go ahead and crank it. As you can see, everything is working. Shut it off. So we'll pause that, but that basically kind of confirms our voltage supply issue. Sort of source is from either this wasn't sitting fully correctly, but I believe our issue is either going to be in here, or just the fuse was not sitting right, or the pins are spread, something to that extent. So we've kind of got it figured out. This is going to be your problem. Just to confirm, we can show you here, and I can actually, we'll start that. So do a crank right now. Shut it off. And that way I can get a cranking event and a no cranking event at the same time on the capture. So if we remove this completely, go ahead. There you go. And we've got the same pattern there that we saw when it was faulted. And then if we simply just put this back in, this is that power supply. Go ahead. There you go. So something with that power supply from that fuse, but it's definitely not going to be a faulty bad computer, as it could be easily made a bad call based off of the trouble codes. And not that we probably need to, but just to look at it out of curiosity, this is where we cranked it, duplicated it, and cranked again after putting the fuse back in. So just out of curiosity, let's see what the known good portion of this situation looks like. So both the power feeds, which should be 3. Let me separate the yellow just so that you can see. There you go. So all the power feeds are right at about the same level. So we're not dropping anything crazy. to the point where the computer is going to wig out. So they're all at about 10 volts or whatnot during the cranking event. So that's a proper operating state where all power feeds to the computer are good and can handle the load, fully being supplied without any dropouts or issues. All right, guys, so I'm back from my friend's shop. I think he's going to go ahead try to locate a fuse box. But before so, he's going to open it up, see if he sees anything. Other than that, if there's any issues, he might just make an external fuse feed to the computer, wire up correctly or whatnot. There's probably many ways to rectify the issue if fuse box is not sourceable. But I know on this one, I didn't take something apart and pinpoint something directly to you guys, but I tried my best to show you the true issue or source of the problem, which is a voltage feed issue. And we clearly found it there at the fuse box. Something was going on there with it. But even after I fully seated the fuse, we couldn't get it to happen again. So I think that's the best that I can do to show you guys what can cause that trouble code and situation. It's very easy to shoot from the hip and call a bad computer, only to be left with the same problem. So this is, I think, now my third F150 with starting issues or no starting issues, where possibly PCM looks to be at fault. Most of the time it might not be, but you have to do these type of testings to determine if it is or not. On this one, clearly, I'm glad that we did and didn't make the wrong call. So now my friend and his customer will get this all fixed and done and can move on from there. So that's all on this one. Hope you enjoyed it, and we'll catch you on the next one.